Algebra 1, Lesson 70, Probability and Designated Order. Some of you might view these as trick questions. There's a key to finding the difference between these questions that will help you. And the key is that probability is related to independent events, which means something that, or the chances of it being successful have nothing to do with anything in the past or anything in the future. So, that's what we call an independent event. Examples of independent events are dice rolls, or flipping a coin, or drawing a card out of a magician's deck at random. Independent event has nothing to do with past events. Now, some precursor information that you're going to want to know to solve these problems. This is information that the book just takes for granted and assumes that everyone should know. A typical dice has 6 sides. Some of you are laughing. Some people don't know. So a dice has 6 sides. They usually look like this. 1, 2, 3, 4, 5, and 6. So that's the first bit of information. Next bit of information, you're going to laugh again. A coin has 2 sides. Yep, so that's the next bit of information. Next 2 bits of information, a little bit more obscure, but it has to do with a deck of cards. So, deck of cards contains 52 cards. So, and the reason why I'm bringing this up is because every time I teach probability, the problem, it seems like the textbook, no matter which one we use, is always going to bring up a dice, a coin, or a deck of cards. Now, a deck of cards has 52 cards. Now, a deck of cards gets a little bit tricky. Within these 52 cards, there are 26 black and there are 26 red cards. And then also of that 52 cards, the 26 black cards and red cards are broken up into 2 more groups. There are 13 clubs, which are black. So the clubs are black. And then there are 13 spades, which are also black cards. And then in the red cards, we have 13 hearts. And then we have 13 diamonds. Now, these 4 groups are what we call the 4 suits. Right, in the deck of cards. So 26 black, 26 red, 13 clubs, 13 spades, 13 hearts, 13 diamonds, 52 cards total. Now, all of this information is important for probability because the key to probability is this fraction. Number of possible outcomes or possibilities. Or, whoops, sorry. Let me start over. Different color. Let's go with blue. Sorry, it's this fraction. It's number of desired outcomes over the number of possibilities. Well, I forget how to spell possibilities. Ignore my spelling. I don't teach English. I teach math. Okay. So, for example, in a coin toss, if I want the coin to land on heads, I have 1 desired outcome. How many possibilities are there? 2. So, 1 out of 2 are the odds that I will get heads. Now, let's talk about a dice. Now, dice outcome can be a little bit tricky. Oh, sorry, that's another bit of information. So a dice has 6 sides, so normally that's 6 outcomes. However, rolling 2 dice has 36 outcomes. The way they get that, they make this little chart here. You could think of it like a square. You have one side of 6, the area being 36. Or you could say 6 outcomes times 6 outcomes, 36. Or you can remember, if you roll 2 dice, there's 36 outcomes. So let's say I'm rolling one dice. And I want to get a 4. How many 4s are on one die? Well, there's one desired outcome. How many possibilities? There are 6 possibilities. So the possibility of rolling a 4 is 1 out of 6. I can't spell today. Now, let's say I'm rolling 2 dice. And out of 2 dice, I want to roll a 4. So 2 times the dice. How many possibilities are there to get a 4? Well, I could have 1 and 3. I could roll 2 and 2. I could roll 3 and 1. Yes, that is a different possibility. Some of you are laughing like, no, we already said 1 and 3. Nope, different possibility. What if dice A gets 3, dice B gets 1? Totally different scenario. Game changer. This one doesn't change because they both read the same. Any other ways I can get 4 with 2 dice? I don't think so. That's it. So 3. So I have 3 possible outcomes, because it's not possible to roll 0 out of, like we already established, 3 desired outcomes out of 36 possible. So that means my chances are 1 in 12 to roll a 4. And that's it for probability. Let's talk about designated order. Now, designated order is different from probability in that it is not independent. All of these are independent events. And the way that they'll trick you is they'll say, Thomas Thomas flipped a coin 3 times. All 3 times he got heads. What's the probability of him getting heads the 4th time? Well, the answer is 1 out of 2, because it's an independent action. Flipping a coin is independent. It doesn't depend on previous information. It doesn't matter what the previous 3, 10, 15, or 100 coin flips were. You're judging one flip of the coin, which is going to have 2 possible outcomes. There's 1 desirable outcome, so the probability is 1 out of 2. And that's where it tricks most people. So now we're going to talk about designated order. Designated order is different from probability in that it depends on the past. A good way to explain this, and the book does it well, is with a tree diagram. Now, what they're asking here is, let's say we wanted to know what's the probability of me flipping a coin and getting heads 3 times in a row, right? So, to do this designated order, what we're doing is we're taking multiple probabilities, which is I want to flip a coin 3 times, 1, 2, 3, and I want the answer to be heads all 3 times. So what we do here for designated order is we take however many probabilities there are, how many events there are, and we multiply those probabilities by each other to get your answer. So in the first coin toss, what is the probability that I will get heads? The desirable outcome is 1. Possible outcomes, 2. Second flip of the coin. What is the probability that I will get heads? Well, desirable outcome, 1. Possible outcomes, 2. Okay. Third flip of the coin. Same thing. I want 1 outcome. There's a possibility of 2 outcomes. So to find the designated order of me getting heads 3 times in a row, I have to multiply all 3 of these. So 1/2 times 1/2 is 1/4. Then 1/4 times 1/2 is 1/8. So I have a 1 in, whoops, I cannot write today. I have a 1 in 8 chance or probability of getting heads 3 times in a row. Let's see if I can find another example for this. Okay, here's a good one. They have this spinning chart, right? They say that this spinner is spun 2 times. What's the probability of the spinner stopping on a 4 and then a 3? So, again, 2 probabilities. I'm doing 2 spins, so I got 2 spaces. I'm going to multiply those probabilities. The first, I want to get a 4, right? So if you look back at the spinner, there's only 1 4 on there. So that is 1 desired outcome. How many options? There are 4 options. 1 desired outcome out of 4 possibilities. And then on the next spin, I want to get a 3. So 1 3 on there. That's 1 desired option out of 4 possibilities. So I multiply 1/4 times 1/4 equals 1/4 16, and that is the probability. All right, well, that's it for this lesson. If you have any questions, let me know on Moodle, and I will see you in class.